Okay, guys. In this lecture, we are going to talk about how to solve what we call rational integrals. Okay, or typically, let me clean the board first. Okay, what are rational integrals? So let's talk about rational integrals. Okay, so basically, what do you want to solve? You want to solve an integral where you have that you want to solve an integral of p1 of x divided by p2 of x in dx, where p1 and p2 are polynomials. So basically, this kind of function is called rational functions. Rational functions. So what are the steps? So let's write an example of this. It could be integral of x cubed plus x minus 1 over x squared minus x plus 1 in dx, or maybe integral of x squared plus 1 over x to power 5 minus x3 plus x in dx. Okay, so it could be any polynomial over any other polynomial. The step to solve this kind of integrals are the following. First of all, okay, so please, before giving the step, let me record that p1 is the numerator. Okay, is the numerator, and p2 is the denominator. Okay, if you want, please, if it's better for you, I think probably let's write it like the integral of p of the numerator divided by p denominator. So yes, this will be much more intuitive. So pd means the denominator. The denominator. Okay, first of all, the first thing to do is that you have to check if the degree of the numerator is greater than the degree of PD. Okay, this is the first step. Excuse me. This is the excuse me. This the pen is getting crazy. Okay, nice. This is the first step. For example, here in this example, the degree of the numerator is greater than the degree of the denominator, but here no. Okay. So step 2, if step 1 is if step 1 is yes, perform the Euclidean, it's called Euclidean division. Okay, we will see what is the Euclidean division. 3. So if it is yes, so you just do step 2 only if step 1 is yes. 3. Factorize. Okay, so factorize PD of x. Okay. 4. Write Pn of x. So write the function in simple fractions. Okay, we will see it. Okay, write the function in simple fraction by using the identification. Is that clear? And fourth, 5, finally integrate the simple factor. Okay, integrate those simple factor, those simple factors to get your answer, to get the answer. Okay, these are the steps to solve this kind of integrals. So we have 5 steps or 4 recording. Nice. Maybe I think it could be great if we do an example. Okay, this could be here the step is not greater or equal. Okay, it is greater, so not greater or equal. So let me do, for example, I don't want to make the lecture very long, so let's take the integral of x squared of plus 1 over x squared, let's say x squared plus 2x minus 3 in dx. Okay, so as one can see, you can easily see that the integral is it's one of the is the kind that we are trying to solve, because it is rational, right? Polynomial over polynomial. Good. Maybe so first step, so the first step says, good, we choose we first check check if the degree of the numerator is greater than the degree of the denominator, right? Or greater or equal. Yes, in this case the degree of the numerator is 2, the degree of the denominator is 2, so we have 2 is equal to 2, so we have to do the step 2. Yes or not? Step 2 says do the Euclidean division. Euclidean division means that I will take my numerator x squared plus 1 and divide it by x squared plus 2x minus 3. Okay, you did this kind of division is something that maybe you did it at the high school. X squared divided by x squared is what? 1. It's come 1. 1 times 1 x squared. No, 1 times x squared, I mean. When it's come here, it become minus x squared, right? 1 times 3 times 2x is 2x. It become minus 2x. Then 1 times minus 3 is minus 3. It can become plus 3, right? So it become x squared and x squared goes, and we remain with minus 2x. Yes, plus 4, because we sum this one with this 3. Nice. So now I can no more divide this stuff by x squared, right? So I can write down that my function will become, so I mean x squared plus 1 over x squared, the function over x squared plus 2x minus 3. Let me write it, let me cancel and write better as it's the example. So x squared plus 1 over x squared minus 2 plus 2x minus 3 is actually equal to what? To yes, that so this is what we this is how we perform. So I forget to, this is the second step. This is called the Euclidean division. We stop dividing here because we can no more divide 2x by x squared, right? So when you finish, this is you first write the result, that is 1, right? Then plus What is this part? Is the part that you didn't divide, yes or not? So you take the part that you didn't divide and you write it over the denominator, because it's exactly the part that you wasn't able to divide, yes or not? So in other words, the integral of x squared plus 1 over x squared plus 2x minus 3 that we had at the beginning becomes just the integral of 1 plus minus 2x plus 4 over x squared plus 2x. Yes or not? At this point, we say is that, so this is what we call, this step conclude the Euclidean division, right? Now, when you reach this step, if it is possible, for example, if, what is the derivative of this stuff below? The derivative, 2x plus 2. Yes, the derivative of the stuff below is 2x plus 2. But unfortunately, it is not up, it is not 2x plus 2. If it was the case, I would have said f prime over f. But it isn't the case, right? So what I should proceed with the to the third step. The third step says that even if you don't see, never mind. So if you reach here, you can just follow the step. The third step says factorize the denominator. So I have to factorize this guy, right? So we have x squared plus 2x. So plus 2x minus 3. To factorize it, I can use the delta as it's a polynomial of second degree, right? That will be 4 minus 4 multiplied by minus 3, right? Because the a is 1. So it will be 16. What? Can you repeat your question, please? But we are finding the discrete. How do you factorize a polynomial of second degree? You find the roots and you factorize it. But we are finding the root with the delta. Don't you know the delta, the discriminant method? By the way, okay, so let me to find the root, we have the two root x1. Once we find the delta, that is here, first root will be minus b, which is minus 2, plus or minus the root divided by 2. Okay, this will be minus 2 plus or minus 4 divided by 2. So you can see that the roots are going to be 1 is minus 3 and the other is 1. When you find the root, it means that the denominator is x minus the first root, so it will be x plus 3 multiplied by x minus 1. Okay, if you expand this, we turn back to this, right? So it means that our function, the function we want to integrate, can be written like 1 plus minus 2x plus 4 divided by x plus 3 multiplied by x minus 1, right? Now we are now able to, so this we factorize the denominator. The fourth step says that write the function as please write the function as simple factors. Okay, as simple factors by using the identification. How do you do it here? When you factorize the denominator, you see that this denominator is given by the product. This is a polynomial of order 1, right? Multiplied by another polynomial of order 1. It means that once you factorize, how to write the simple factor? The function will become 1 over. So I have x minus x plus 3, right? That I can directly, excuse me. So I have one, when I are doing so this is a polynomial of order 1. So you will identify by using, so you will just write a here. For the a is a constant, okay? A constant is a polynomial of order 0. So polynomial of order 1, if you have polynomial of order 1, you use by identification polynomial of order 0, okay? You use for identification. Then for the never mind, you will understand. Then plus the order was x minus 1, right? Also here it's a polynomial of a degree what? 1. So we will use a polynomial of degree 0. Doubts? So we will find, so what are we trying to do? We are trying to write this function in simple fractions. Is that clear? You got the idea? Now, how do we find a and b? We find a and b by identification, like this. So by saying that we sum up this and we identify it with this. Is that clear? So let's sum it. What will the common denominator will be? X plus 3 multiplied by x minus 1. Then we'll have ax minus a. Yes or not? Excuse me. It will be ax minus a, then plus bx 3b, right? And finally you can summarize like this by saying this is x plus 3 into x minus 1. And when you take a, what do you do here? You take the stuff with x together, so it will be a plus b, yes or not, times x, and plus minus a plus 3b, right? But you want to identify this should be equal to what? To minus 2x plus 4, right? Divided by x minus x plus 3 into x minus 1. For this to happen, you see that this a plus b should be minus 2. So for this to happen, a plus b should be minus 2, and minus a plus 3b should be 4, right? This is a system with two equations and two unknowns. For example, from the first equation we get that a is nothing else than minus 2 minus b, right? So we put it in the equation. The second we have minus a plus 3 into minus 2 minus excuse me, I make the mistake. So putting it in the first equation, a will become minus 2 minus b plus 3b equal to 4, right? So it gives us 2 plus 4b. Am I right? Because it's plus b plus 3b plus 4b equal 4. Okay, thus b is equal to half. You saw, because this is equivalent to says that 4b equal to 2. Okay, so b is equal to half. Now as b is half, we get also that a is minus 2 plus half equal to minus 3 half. Okay, so we got a and b, so we can now go back and says that okay, the function, I remind you that we can just now go back and say f of x equal, look, so f of x will be half over minus 3 half over, so f of x is, no, it was 1, then plus minus 3 half over x plus 3, yes or not, plus half over x minus 1. Now look, you have done, because this function is very easy to integrate. If now I put the integral, I will put the integral here, yes or not, but it will, what is the integral of 1? Yeah, so this will be x plus, now let me write it, it will be the integral of this plus the integral of this plus the integral of this, right? But let me make it, I can take, it will be like the integral of 1 in dx, right? I can take the minus 3 over 2, integral of 1 of x plus 3 in dx, plus 1 over 2 integral of 1 over x minus 1, yes or not? So it is x minus 3 over 2 ln of absolute value of x plus 3, right? Plus 1 over 2 ln of absolute value of x minus 1 plus c. So this concludes the integration, this integration we wanted to do, yes or not? So we follow exactly the step I told you, okay? Then so just the let's say the step that is very important is the fourth one, how to do the identification, right? So if you have, so you understood, for example, that if your denominator gives you some factor like x minus x1 into x minus x2 dash 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 into x minus xn, right? For you will identify it by doing a1 divided by x minus x1, right? One constant for any fact plus a2 divided by x minus x2 dash 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 an divided by. Is that clear? Now this is the first case. Second case, maybe your denominator give you x minus x1, that come once, then x minus x2 square, then x minus x3. Excuse me, let me, this went wrong. X minus x3. Okay, when it comes like this, what do you do? In this case, this guy is order 1, right? So what you do? You do, it will be a1, a constant divided by x minus x1, no problem, right? Plus also x minus x3 come only 1, so yes or not? So it will be a3 divided by x minus, yes or not? Now, so this constant that I'm calling, you can call it a, b, c, or and d, no problem, right? Then for this guy, when the guy come with the square like this, there's two things to do. First, you do a2, the constant, divided by x minus x2, okay? Then plus, and as he come twice, you need to, okay? But it is a4 divided by x minus x square, all square. Is that clear? You see how to. So for example, if the example is that if the function give you like 2x plus, I don't know, 3x square minus 1 divided by x minus 1 square multiplied by x plus 2. The identification will be 2x plus. For x plus 2, you will use a divided by x plus 2, and you have done, right? But for x minus 1, you will first do one constant b divided by x minus 1, then another constant divided by x minus 1. Is that clear? And now you can do the identification, okay? The third and last case that you can see for the denominator may be like, you know that, for example, ax squared plus bx plus c. Maybe you get that the denominator is something like this, multiplied then by x minus x1, x minus x2. Why do I, you know that they are polynomial of second order that you cannot factorize more. Okay, so maybe you find that, for example, if the denominator is like this, maybe you get a polynomial of second order that you cannot factorize more. What will you do in this case? The identification for this guy and this guy is simple, yes or not? It will be just a divided by x minus x1 plus b divided by x minus x2. But for this guy, look, it is a polynomial of which order? This guy, 2. So it is ax squared. Okay, let me use big A here, because let me use big A here to not make confused with the, yes or not? So this is, I mean, you should not, I don't mean the same A. Okay, so this is ax squared plus bx plus c. Now you cannot identify you cannot, in this identification, as you have second order at the denominator, you should have at least first order at the numerator. So you will use cx plus d, yes or not? This is first order. If you have second order, you use first. If you have first order, you use zero order. Is that clear? That's the stuff. So the identification will come out like this, and you should find C, D, A, and B. Yes. So an example for this could be, suppose you get that your denominator gives you x multiplied by x squared plus 1 multiplied by x minus 3. You see, this x squared plus 1, you cannot factorize it more. Is that clear? So it will be a divided by x plus, you will use bx plus c divided by x squared plus 1, and then plus d divided by x minus 3. Is that clear? Good. So this concludes this short lecture about how to solve rational integrals, and we will use this theory to solve MCQ related to rational integrals. Okay. Thanks for your attention.